Hi everybody, today we're going to be talking about solubility graphs, and basically each of the curves on the graph is going to represent the solubility for each compound in 100 grams of water, which is the same as 100 mLs of water, because the density of water is 1 gram per ml, so 100 grams of water is the same as 100 mLs of water. And the range on the x-axis will be the temperature, and that's going from 0 degrees Celsius, which is freezing, to 100 degrees Celsius, which is boiling. And then you're going to also hear me talking about supersaturated and unsaturated solutions. So if there's an area above the curve, that solution is going to be called supersaturated. And this will make more sense when I show you the graph in a moment. And the area below the curve is going to be unsaturated. Solubility of most solids is going to increase as temperature increases, and that's because of kinetic energy. Okay, now with gases, it's the opposite. Gases' solubility actually decreases as the temperature increases. And that's because as the kinetic energy of the gas solute increases, its molecules have a greater tendency to escape the attraction of the solvent molecules and return it to the gas phase. So basically, because the gases are already high energy, they don't really dissolve very well in a solvent. Okay, so therefore, the solubility of gases is opposite that of the solids. Okay, so solids, as you increase the temperature, there's more movement of molecules, more things bumping into each other. That solid will dissolve. But with gases, as the temperature increases, it's actually going to diminish the solubility of those gases. Okay, so earlier I talked about these words unsaturated, saturated, and supersaturated. And what you want to kind of think about with these is that one of them is not really good enough, one of them is just right, and one of them is a little too much. Okay, so if you imagine, like Kool-Aid, okay? You're making the powder solution and you're mixing it in the water, okay? Now, if you put way too much of that powdered sugar mix into the water, and it's so sweet that you can barely drink it, and a lot of that sugar is going to the bottom because, the water just can't really dissolve everything, that's called a supersaturated solution. So that's kind of like overkill, okay? A saturated solution is, the right amount of sugar with the water. It tastes just as it should, okay? And then unsaturated is, it's kind of watered down. It could still dissolve a little bit more, okay? So for the sake of our class, what you're going to have to know for unsaturated is, so with an unsaturated solution, you have a solute that could still, you could still kind of add more to the solvent, and, an unsaturated solution could handle more. Whereas a saturated solution is, just right. You have the right amount of solute per solvent. And then again, like I mentioned earlier, a supersaturated solution is kind of just way too overfilled, and the crystals actually will not be able to dissolve because there will not be enough of the solute to kind of accommodate all of the solute that's in that solution. Okay, so when we talk about what happens if I add a crystal to that, okay, well, think about salt. Salt is a lattice of sodium and chlorine, in this net arrangement. So it is a continuous arrangement that makes it a crystal. And if you put that in an unsaturated solution, it would still be able to accommodate that crystal and dissolve more. Okay, with a saturated solution, again, this is the one that's just right. If you add more of the salt, it actually won't dissolve. It's reached its capacity, and this is how much it can dissolve. Okay, and then with the supersaturated solution, that's when you see those crystals kind of sinking to the bottom. So if you've ever made a tea that was way too sweet, you would put way too much sugar in it, some of that sugar will sink to the bottom. So that's a super saturated solution. Okay, so now we're going to talk about how to read a solubility graph. So on the y-axis, you see that it says grams of solute per 100 grams of water. So that's how much of the solute is dissolving in 100 grams or also 100 milliliters of water. And on the on the x-axis, you see temperature in degrees Celsius. So that's the temperature at which that amount of solute dissolves. So really, it just needs a little bit of practice. Just looking at the graph and finding each solution and how much dissolves at a given temperature. So like always, the best way to do this with some practice. So the first one says, what is the solubility of potassium nitrate at 50 degrees Celsius in 100 grams of water? So what I'm going to do is find 50 degrees Celsius. And I'm going to find potassium nitrate, which is right here. Okay, so everything has to be in respect to this curve. So I'm going to take the 50 degrees Celsius mark, and I'm just going to follow it up until it hits potassium nitrate at the curve. And it's about right here at 80 degrees or 80 grams. So like right here. So 80 grams of potassium nitrate dissolves at 50 degrees Celsius. Okay? So the next one says, how much ammonium chloride can dissolve in 100 grams of water at 90 degrees? So I'm going to find 90 degrees Celsius, which is right here. Then ammonium chloride looks like it's this one. Okay, so I want to see how much is going to dissolve at 90 degrees. So that's about right here. And that's 70 grams. The next one, if 80 grams of potassium nitrate is placed in 100 grams of water at 40 degrees, is the solution unsaturated, saturated, or supersaturated? Okay, well, if it's going to be above the curve, it's going to be a supersaturated solution. On the curve is a saturated solution, and then below the curve is unsaturated solution. So here is potassium nitrate. Okay, and I'm looking at 40 degrees Celsius, so that's right here. So they're saying, okay, if it's 80 grams, well, 80 grams is right here, so that's above the curve. Therefore, that is supersaturated. When solute is saturated, which solute is saturated when 20 grams of the solute is dissolved in 100 grams of water at 65 degrees Celsius? Okay, well, I'm going to find 65 degrees Celsius, which is about right here, and 20 grams of the solute. So I'm looking for at 65 degrees Celsius, what has 20 grams of solubility? And it looks like it's this guy here. And that is the curve for ammonia, NH3. Okay, so I went to 20 and 65, and it hits right here on the curve. So that is NH3. For the next one, it says how much potassium chlorate can dissolve in 200 grams of water at 0 degrees Celsius. Okay, well, since the graph is for 100 grams of water, if I'm looking at 200 grams, all we're going to do is double the solubility. So at 0 degrees Celsius, the solubility is about 5 grams. But remember, that's 5 grams per 100 grams of water. Therefore, it's going to be 10 grams of potassium chlorate dissolved in 200 grams of water. Okay, so your answer would be 10 grams. Which solute has the most rapid increase in solubility? Well, what you're looking for here is which one has the most dramatic change. So a lot of them are steadily increasing. Some of them barely move. Like for example, sodium chloride, like here's the curve for sodium chloride, it barely goes up. This one, but the one that has the most drastic change as temperature increases looks like it's potassium nitrate. So that is the one that has the most rapid increase. For the next one, it says, which two salts are identical in solubility at 95 degrees Celsius? So I found 95 degrees Celsius on the graph, and then I just saw, okay, who has the same solubility? And it looks like it's potassium chloride and potassium chlorate. Okay, and I know they have the same solubility because they actually intersect here. Last one, if 50 grams of ammonia is placed in 100 grams of water at 10 degrees Celsius, is it unsaturated, saturated, or supersaturated? So with whether it's unsaturated or saturated, you just have to look at where it hits on the line. If it's above it or below it, that tells you a lot. So I'm going to find ammonia. Okay, ammonia is right here. It's actually a gas. So remember, solubility decreases as temperature increases for gases. Okay, I'm going to find 10 degrees Celsius and 50 grams. So here's 10 degrees Celsius, here's 50 grams, and that's right here. So because it's below the line, it's going to be unsaturated. Okay, if it was above the line, it would have been supersaturated, and if it was right on the curve here, that is saturated. But because it's down here, that's unsaturated. And then the very last question says, which are the gases on the solubility graph? Okay, well, the gases are the ones that decrease as temperature increases. So ammonia is one of them. And also cerium sulfate is the other because it is going down. Okay, so this is a gas and this is a gas. Okay, I hope this helps, and you can now work on your practice packet.